Hello everyone, I am Akhilesh Kumar Shrivastava from ABS Engineering College, Ghaziabad. In the series of the operating system lectures, we have already discussed about the cooperating and the competing processes. We are done with the critical section problem and entry and the exit sections. We have seen a solution to the critical section problem, which was the use of the lock variable, and then we have seen the solution with the test set lock, which was just a variation of the lock variable solution. In today's lecture, we will see some more solutions to this. For example, use of the lock and the turn variable, and then we will discuss about the Peterson solution. We will then see what are other solutions possible than the Peterson and the lock variable solution. So, the outline of today's lecture will be, we will be having a recap of the cooperating and the competing processes. We will have a recap of need of the synchronization. We will summarize the solutions discussed so far, and then we will use the turn, interest and the Peterson solution subsequently. So, about the cooperating process, I told you that if there is a process which generates something and the other process consumes that thing, we will say that those two processes are the cooperating one. We have taken an example of the IRCTC booking, in which there is a process which is trying to use the number of the seats for inquiry, and the other process is trying to modify the seats through the booking and the cancellation of the tickets. So, that will be those three types of the process will be the competing processes, because one of the processes trying to use that resource or the number of seats, that will be the shared variable, and the other one will be trying to modify that variable, and the other one also will try to modify the variable. So, the number of seats are modified in the case of cancellation, number of seats will be modified in the case of booking, and the number of seats will be seen only or viewed only in the case of the inquiry, ticket inquiry. So, the cooperating process and the competing processes we have seen with the example of the two processes P1 and P2, which are trying to use the common variable count. Both the processes are updating these values, and we need the consistent value of this count after the execution of the P1 and the P2 process in any sequence. We have seen also that when the values of P1 and P2 are updated, so they are actually consistent if we allow P1 process to execute completely and then we allow the P2 process to execute completely. When we divide the count statement or the updation in the count variable in the assembly language statements, so the count plus plus is given by these three statements and count minus minus is given by these three statements. If we allow the preemptions to take place in between, we have seen with this example that the value of count comes to 6, and with this we see that the count value comes to 4 if we have initialized the value of count as 5. But what we want that after an increment the value of count should be 6, and after the decrement the count value should be 5. So, consistent value of the count will be 5, but we are obtaining 6 and 4 here, that is wrong. So, whichever process is finishing first is updating the value of the count, and there is a race between the two processes to access to the count variable. So, there is a race condition here. Now, after this we have discussed about the critical section. Obviously, wherever we are using the count variables updation, that will be the critical section. So, any other part of the code will be said to be the non-critical section. So, part of code that is using the shared variable, that is the critical section, and the part of the code that is not using the shared variable is the non-critical section. So, critical section and non-critical section. In the same process or in the same program, we can use the shared variable multiple times. So, there will be several critical sections possible in a program. A synchronization mechanism is required to access to the critical section. It means that if one process is executing the critical section, it means using the shared variable, the other process should not be allowed to use the critical section. So, we should be maintaining this order, or we should be maintaining this scheme such that we obtain the consistent value of the shared variable. So, this will be said to be the solution to the critical section problem will be the synchronization mechanism, and the synchronization mechanism involves the addition of the entry section and the exit section above and below the critical section. In the entry section, we will be setting up some conditions, or we will be checking some conditions, and based on those conditions and setting off the values, we can enter the critical section, and if we have set any value, that value will be removed while exiting the critical section. So, if we have applied any condition at the exit of the critical section or while exiting the critical section, you should remove those conditions. So, we are applying a line of code, a piece of code above and below the critical section, known as the entry section and the critical exit section. Any other part of the code which is written in the program is known as the remainder section. So, there are 4 sections in your programs now. One is the entry section, critical section, exit section. Any other part of the code will be the remainder section. So, part above the entry section is the remainder section, part below the exit section is also the remainder section. We have seen with the example the first solution to this problem with the help of the lock variable. We have seen that there should be a lock. If the value of lock is 0, it means we can enter the critical section. If the value of lock is 1, it means somebody is already executing the critical section. So, the others should be restricted. In the busy waiting solution, we will keep checking the value of lock. We have seen with the example of the knocking at the door of the dressing room continuously if somebody is already in. So, lock variable can be used, and if the lock value is not desirable as of you, then you should keep waiting. So, this is the busy waiting solution in which the CPU is always busy checking the condition. So, this is the entry condition where the lock value is checked and the lock value is set to 1 while entering the critical section, and when the critical section execution is completed, the lock value is done to 0 again. Fine. Now, we have seen that there were certain problems with the lock variable. One was, if we are executing, when we expand this code in the, let us say the assembly language code, in the assembly language code, the value of the lock is taken in some register, and then that value is checked with 0. If it is 0, then we set the value of lock as 1 and then enter the critical section. So, these lines were updated like this: load value of lock in, let us say, some R0. The statement number 2 says compare R0 with 0. Third says jump if not 0 to statement number 1. Fourth is setting the value of set #1 in lock, and if it is so, enter the critical section, and while exiting the critical section, set 0 value in the lock. We have seen that in this solution there was some problem when we are allowing the preemptions to take place in between, then many processes can enter the critical section simultaneously. So, mutual exclusion, the basic thing, cannot be achieved here. Solution to this was that we exchange the statement number 2 and 4, or what we can say that we are not exchanging, we are bringing the statement number 4 up. So, the statement execution will be first loading the value of lock in some variable, in some register, and then setting a value 1 here. So, lock 1 was set here in the statement number 2, and then we were checking the value of R0, and accordingly we were either going to first statement or we were entering the critical section. So, this also had a problem if the preemption is allowed in between 1 and 2. If we allow the statement number 1 and 2 to run at the same time, it means as a unified statement, then we achieve the mutual exclusion. But this is like execution of the two statements simultaneously can be allowed only through the hardware solution. So, there should be a hardware wherein two statements will be fabricated or as a statement, and then you have to execute those statements. So, this was called the TSL, test set lock. So, test set lock solution is suffering with the not architectural neutral. So, we want to design a solution which is architectural neutral. So, for that we have a solution known as the strict alteration approach. What will the strict alteration do? Strict alteration is a two process solution. In the two process solution, first P0 process will run, then P1 will run, and then again P0 will run, then P1 run, then again P0 runs, then P1 runs. It means there is alteration of the execution. So, this is a software mechanism. Here is the solution for P0 process. Let us take a turn variable. If the turn value is 0, it means the process 0 will execute. After executing, the P0 process sets the value of turn as 1. It means now it gives the chance to the process number 0 to enter the critical section. And when the value of turn is 1, process number P1 enters the critical section, and while exiting the critical section, it will set the value of turn as 0, so that process number P0 enters the critical section. So, it is a very good mechanism by which one is allowing the other one to enter the critical section, and the other one is allowing the first one to enter the critical section. So, there is a strict alteration maintained. So, what is the benefit of this strict alteration? That one process can enter the critical section at a time. Another thing is that bounded wait is satisfied. It is not that a process which wants the execution of the critical section will be allowed to execute it many times, multiple times. So, bounded wait is there, and here you can see that this is the software solution. There is no hardware required here. So, in this process, what is the problem? The problem is, let us say P0 process wants to enter the critical section. It runs its code, and at the end, let us say here it sets the value of turn as 1. Now, P1 process has a turn 1, but P1 does not want to enter the critical section. P1 does not want to enter the critical section means P1 will neither execute its code nor will set the value of turn as 0. So, the turn of 0 will not come. So, it means that a process P1 does not have to enter the critical section, and it is not allowing the P0 to enter the critical section. It means the progress property here is not satisfied. Okay? So, the progress property here is not satisfied. Okay? This has already been discussed. Bounded wait is guaranteed, mutual exclusion is guaranteed, one process will enter the critical section at a time, but progress property is not guaranteed. So, why not to take the choice of the person who wants to enter the critical section? Here what we have taken in the last solution, the turn. Now, let us take interest. If somebody is interested, only then he will enter the critical section. If somebody is not interested, we will not allow that person to enter the critical section. So, the progress property which was actually disturbed, or progress property which was not getting satisfied in the earlier solution, may get resolved here. Let us take the interest. So, let us say we have the interest array or interested array, and it has two values, okay, and both are initialized to 0. It means that none of the two processes want to enter the critical section. Okay. So, interested 0 means the process number 0, and interested 1 means process number 1. In short, you can write I0 and I1. So, I0 true and I1 is also true. इसका मतलब क्या है कि दोनों process एक साथ interested हैं. We'll see what will happen. I0 interested है, I1 interested नहीं है. ठीक है, P0 process को enter करा दीजिए critical section. I0 interested नहीं है, I1 interested है. Let P1 process execute the critical section. P0 process भी false है, का interest भी false है, P1 का भी interest false है, we will not allow any other process to enter the critical section. So, what will be the problem with this? We are just going to check this. P0 process non-critical section है ये, फिर we are going to set the value of interest as true. So, interested variable of P0 process is set as true, it means this process is interested. In case the other process is interested also, if the interest of one is true, we will keep waiting, busy waiting solution है ये. और अगर interest 1 0 हो जाएगा, then we will enter the critical section. It means the P0 process enters the critical section at this time. So, P0 enters the critical section only if interest 1 is 0. When it completes the execution to the critical section, it sets the interested value as false. It means now P0 has executed the critical section, so it sets its value as false, so that the other process can enter the critical section. Okay. Similar is the case here for the P1 process. It wants to enter the critical section, it will set its interest as true. If the other process is interested already, don't enter the critical section and keep waiting. If the interest value of 0 process means the other process is 0, it means false, enter the critical section, and while exiting the critical section, set your interest or process number 1's interest as false. Fine. So, it is the solution in which the interest is also taken for a process. Now, here obviously the mutual exclusion is guaranteed, only one process can enter the critical section. Progress is also guaranteed. If a process wants to enter the critical section, then only it will set its interest. If a process does not have to enter the critical section, it will not check its interest, set its interest. Okay. Now, bounded wait is not guaranteed. We are not alternating in between. So, since we are not alternating, it means the bounded wait condition is not satisfied here. Okay. A process can enter in the critical section any number of times. If it is in the loop, it will keep executing the critical section. Now, architectural neutral है क्योंकि ये software solution है. This is the architectural neutral solution. Now, why not we should use the scheme of lock and turn simultaneously. Okay. Before this, let us see this again, this solution again. This P0 process sets its interest at true and enters the critical section. Fine. Then the P1 process, since this is this process P0 has already entered the critical section, the P1 process will see its interest as 1. P1 has also set its interest as true, and it will be waiting. Fine. Now, P0 process after exiting the critical section sets its value as false, and then it wants to enter the critical section again, so it again sets its value as true. It goes again and sets its value as true. Since interested 1 is also true and interested 0 is also true, this process will also wait. Since this process will wait, it means P0 is waiting, P1 is waiting, they are in the deadlock. Neither P1 is allowing P2 to enter, nor P1 is allowing, neither P0 is allowing P1 to enter, nor P1 is allowing P0 to enter. So, there is a deadlock condition here. Now, let us deal with the solution, which actually is a solution that combines the interest and the turn. This is known as the Peterson solution. So, this is the first acceptable solution between the two processes. So, first we should learn that this is a two process solution. This cannot be applied for multiple processes. So, this is a two process solution. So, there are two processes here, let us say P0 and P1. For understanding this algorithm, understanding this code, let us say there is an interested array for n processes, let us say here it is 2, and it is set as false for both the processes. It has set the value of an interested false, means both the processes are not interested, okay, and there is a turn. Okay, there is a turn. If you have declared it globally, it means that its value will be 0. So, initially turn is 0, it is the turn for the first process. Now, this solution is actually for both the processes. It has been written in general. For example, there is other variable, let us say process is the current process, let us say the current process is 0. So, the other process will be 1 minus 0, it means 1. Let us say the current process is 1, then the other process will be 1 minus 1, it means 0. So, the other process is defined as a variable, current process is passed as a parameter in the entry section, in the code of the entry section. Other process is defined as 1 minus the process. If the current process is 0, the other process will be 1. If the current process is 1, the other process will be 0. Now, we have to set the interest of the current process as true. We have to set the interest of the current process as true. Obviously, we are running it for the current process. So, if it has to execute the critical section, its interest value should be true. Now, turn equals to process. We have set the turn is equals to process. Okay. Now, let us check if the interest of the other process is true and turn is process, means both the conditions should be satisfied at the same time. If the interest of the other process is true and the turn is of the current process, then keep waiting. Okay. If the interest of the other process is true and turn is equals to process, then keep waiting. But if this condition is satisfied, if either of these two conditions are satisfied, enter the critical section. And what to do in the exit? You just have to set the interest as false, interest of the current process as false. Let us execute this process for some instances. The code is written here, we will check it one by one. The P0 process is executing the statement. So, we have numbered these statements 1, 2, 3, 4, 5, 6. So, 1, 2, 3, 4, 5 is in the entry section and 6 is in the exit section. If the entry section statements are satisfied, we will enter the critical section and then we will execute the exit section. So, P0 process executes statement number 1, 2, it means P0 process is setting the other value as 1. Okay. Now, statement number 3 means the interest of the process number 0 is set as true. Okay. So, interest of process number 1 has been set as true. After this, the statement number 4, turn is equals to process, turn equals to process means turn is equals to process number 0. Okay. Now, if interest of 0 process is true, obviously at initial stage the interest of the other process will be false. So, see statement number 5, interest of the other process is true, no, this condition is false. Since this condition is false, the P0 process can enter the critical section. Fine. Now, what about the P1 process? The P1 process is in statement number 1, it has set the other as 0, 1 minus 1. It is seeing that it has to enter the critical section. So, statement number 3 will set its its interest as true. So, I1 is set as true. So, I0 is true and I1 is also true. Okay. Then P1 executes statement number 5 and statement number 5 says if interested of the other process is true, yes, if this is first process, the other process interest is also true, and turn is equals to process. Turn is equals to process, yes, this will set the turn is equals to 1. So, first condition is not satisfied. Even if the second condition is satisfied, both the conditions will be false. Okay. So, if both the conditions, if the other is also true, it means this condition is satisfied and the turn is equals to process, this is also satisfied, it means this process will wait, the P1 process will wait. I again repeat, if the interested of the current process, interested of the other process is true, yes, it is here, interest of 0 is true, and the turn is equals to process, turn is equals to 1, this process will wait, it means it cannot enter the critical section. Now let us say P0 process exits the critical section. When P0 exits the critical section, it will run this statement and I0 will be set as false. Fine. Now P1 process again checks the condition number 5. Condition number 5 says if the interest of the other is true. No, it is false, it has just been set as false. This condition is not satisfied. Since this condition is not satisfied, P1 process can enter the critical section. So we have seen that the mutual exclusion is guaranteed here. Okay, only one process can enter the critical section at the same time. Fine. Now the progress. Let us say a process does not want to enter the critical section. So it will not check the condition, or it will not set the interested as 1. So if it will not set the interested as 1 or true, the progress property is also satisfied. Now this is, we will check about the other two later. Let us check another scenario. So here what is said, we have the 1, 2, 3 statement of the process number 0. So 1, 2, 3 means interested of 0 process has been set as true. Now the preemption, the P1 process executes statement number 1, 2, 3. So 1, 2, 3 means it has also set is interested as true. So 0 process is true, 1 के लिए भी interested true है. Fine. Now P1 process is setting turn variable also as 1. P1 is checking the condition, both the conditions are satisfied, क्योंकि दूसरा भी true है और turn equals to 1 भी, इसलिए ये wait ही करेगा. This will wait. Now the P0 process will check the condition number, will set the turn is equals to 0, and then it executes the statement number 5. Statement number 5 is saying that अगर दूसरे का turn है true है और दूसरे का इंटरेस्ट ट्रू है, यस इस केस में है, दोनों का इंटरेस्ट ट्रू है, और टर्न इज इक्वल्स टू प्रोसेस है, यस 0 है, तो इसका मतलब ये एंटर नहीं कर सकता, तो ये भी वेट करेगा. नाउ अबाउट द P1 प्रोसेस, व्हाट P1 प्रोसेस इज चेकिंग, P1 प्रोसेस इज चेकिंग कि क्या दूसरे प्रोसेस का इंटरेस्ट ट्रू है, यस है ट्रू, 0 प्रोसेस का इंटरेस्ट ट्रू है. क्या टर्न इक्वल्स टू प्रोसेस है, टर्न इक्वल्स टू प्रोसेस तब होता है जब टर्न इक्वल्स टू 1 होता है, यहाँ पे तो टर्न इक्वल्स टू 0 है, इसका मतलब P1 प्रोसेस क्रिटिकल सेक्शन में एंट्री कर सकता है. सो अगेन वी हैव चेक दैट दिस कंडीशन इज satisfied. So now if you execute the statements here also, and then P1 process can enter the critical section only after the P0 exits. So the mutual exclusion property is satisfied. Now alteration is guaranteed. आप देख सकते हैं इस वाले एग्जाम्पल में, नीचे वाले एग्जाम्पल में कि P0 एंटर कर रहा है क्रिटिकल सेक्शन, देन P1 एंटर कर रहा है. आफ्टर दिस P0 will enter and then P1 will enter, then P0 is entered, then P1 will enter. So it means that the bounded weight is satisfied, and architectural neutral भी है solution because this is the softer solution. So these are the references for this lecture. We will see the other solutions on the next term. Thank you.